Session 2021, number 2, exercise number 2. So, studying the motion of an object. Consider a rail A or B located in a vertical plane composed of two straight parts, horizontal part OA and inclined part OB, with an angle of 30 degrees with the horizontal. The two objects S1 and S2 are particle, and you have the mass is equal to 0.08 kilogram. So we have a massless spring, a force constant K equal to 200 Newton per meter. You have the horizontal plane is the one that's passing through containing the point O. So we'll look at the figure. This is the figure here. You have S1 and S2. This is the horizontal and the inclined plane. So read the given also. Launching part 1, launching particle S1. In order to launch S1, it's placed against the free end of the spring. The spring is compressed by a distance D. And then the system is released from rest. So this is very important. هاي الجملة كتير مهمة. When I say the system is compressed by D and then released, this means هيدا D هي عبارة عن it's equals to XM, the maximum compression. Why? Since here we are saying that's released يعني جانا تيكناها from rest. So this means this compression هي بحد ذاتها it's the maximum compression. And when I say from rest, this means that I have V equals to 0. وكلهم بيساعدوني نعرف in order to know that the kinetic energy is 0 and the elastic potential energy is maximum. When the spring returns to its natural length L0, S1 leaves the spring with the velocity V1 parallel to OA. So here we have kinetic energy. And when I say natural length, this means there's no PAE. This means X is equals to 0. ما عندي لا compression ولا elongation. After launching, S1 moving with the velocity V1 collides head on with S2, which is placed initially at rest. So نحن كان عندنا S2 is initially at rest. Okay, and then you have it collides. When I say collision, is not directly that I must use or I must have P before the collision is equals to P after the collision. We have the conservation. Okay, now just after the collision, S1 stops and S2 moves with the velocity V2 parallel to OA and of magnitude V2. So this is after the collision. So after the collision, what do I have? I have S1 stops. This means V1 prime is equals to 0. بينما V2 is equal to 5 meters per second. S1 and S2 moves without friction on AO. This means now without friction, this means that we have conservation of mechanical energy. So خلينا نشوف in the figure how should we talk about this exercise. So what this means, we have S1 كانت compressed initially and then it's released عملت collision. Now صار في عندي يعني before and after the collision and then كملت ال S2 طلعت and then ورجعت نزلت. So the question is apply the law of conservation of linear momentum to show that the magnitude of V1 is V1 equal 5 meters per second. So V1 هي عبارة عن مين؟ V1 it's the speed of S1 just when it collides with S2. This means it's before the collision. So لكن هون we have to find V1 which is before the collision. And قالنا شو هي طيب قالنا applying the law of conservation of linear momentum. So هون بيجي بقول part 1 what do we have? We have a collision. When I say collision, this means P before the collision is equals to P after the collision. And the system taken نحن عم نشتغل فيه هو عبارة عن مين؟ هو عبارة عن S1 and S2 together. So this is the system that we are studying. Okay, so P before the collision is equals to P after the collision. أكيد in terms of vector. Now, when I say P before شو كان عندي؟ كان عندنا P1 and P2. So I'll name it here. It's P1 vector plus P2 vector is equals to P prime 1 vector plus P prime 2 vector. Okay, now this is P before equals to P after. بعدين شو بنعمل؟ Now before the collision كنا بنعرف إنه ال S2 كانت at rest. This means this is equals to 0. And after the collision قلنا ال S1 صار at rest. This means this is equals to 0. So هودي راحوا. And then now I can substitute. So what do I have? I have M1 V1 vector, which we want to find, is equals to M2 and V prime 2 vector. This is after the collision. And then since they are collinear, so بما إنه collinear, then I can take off the vectors, and then we will have M1 V1 is equals to M2 V prime 2. And we already have that the masses are equal. Okay, so نحن معنا الماسses كان عنا is equal to 80 gram. So this means كمان سيفي يشيل M1 and M2. This means that V1 is equals to V prime 2, which was equals to 5 meter per second. كان نحن معنا V prime 2, so it's equal to 5 meter per second. هيك نكون طلعنا V1 before the collision, just before the collision. Now we continue. Part 2, deduce that the collision between S1 and S2 is elastic. In order to verify that it's elastic, this means I must find KE before the collision and KE after the collision, and they must be equal. So KE before the collision, this means it's KE1 plus KE2. You have both S1 and S2. And after the collision, it's KE prime 1 plus KE prime 2. And then now we substitute. Knowing that KE prime 2, knowing that before the collision this is equal to 0, before the collision KE2 is equal to 0, it was at rest, okay, S2, and after the collision KE prime 1 and this is equal to 0 لأنه صارت at rest. Then here we'll have is equals to half M1 V1 square, and we already have the values, so we'll have is equals to 1 joule. The mass is 0.08 kilogram, the speed is 5 meter per second, so we'll have 1 joules. And here we'll have half M2 V prime 2 square, so كمان we'll have it's equal to 1 joules. Since they are equal, so we have KE before equals to KE after طلع equal, this means that it's an elastic collision. Now, part 3, determine the value of D. We already said that this D هي عبارة عن مين؟ هي عبارة عن the maximum compression. Okay, so this is L0. When we say L0 يعني هيك كانت الفigure. This means this was the free length. هون كانت طابق at free length. This is L0. And when شو we compress the spring. When we compress the spring صارت هون الطابق. Okay, so we compressed by a distance D and we release it. We said then this is why we can say that D هي عبارة عن XM. So the question is to find XM, and we already know that there is no friction. And since there is no friction, then this means we can apply the law of conservation of mechanical energy. So the system, I can say here that the system studied is who? It's S1, the spring and earth. The spring and the earth. And we can apply, since there is no friction, so I can say no friction, then I can apply the law of conservation of mechanical energy. Implies ME is constant, conserved. So according to this law, we'll have that ME at which point رح ناخد at the maximum compression. So I will name here a point. I will name it, for example, the point C. And here, this point, I will name it, for example, the point D, big D. So we'll have ME at the point C is equals to ME at the point D. Okay, for S1. And this is, pay attention, this is before the collision, okay? So here, ME at the point C, this is, implies, it's KE C plus PEG at the point C plus PEE at the point C. PEE at the point C, and this is equals to كلهم equals to at the point D, يعني كمان equal KE at the point D plus PEE at the point D. هلا ال PEG is 0, so خلاص ما رح اكتبها. And here كمان PEG at the point C is 0 since what? Since it's on the reference, there's no height. And then we continue. Now, before when it was maximum compressed, at the maximum compression, there's no speed. So this means KE equal to 0. So maximum compression, when I say maximum compression, this means V is equals to 0. So title KEC equal to 0. And at this point D, there's no compression. This means X is equals to 0. So هيدي صارت 0. And then I can substitute. So we still have, this implies PE at the point C. So he half K XM square plus, equal to half, so KE equal to half mvd square. And we already find that vd, which is the v, the speed of S1 before the collision, it's equal to 5 meters per second. So half and half رح يروحوا. And the question is to find xm. So لما نطلع ال xm, we'll put the values, and we have k, it's equals to 200. So I put it here. This means that half times k اللي هي equal to 200 times xm square, which we want to find اللي هي d, is equals to half. So الhalf والhalf فينا نشيلهم قلنا. So it's equals to m اللي هي 0.08 times vd, which is 5 square vd square. And here we can find xm. So xm, so by calculation, will be equals to 0.1 meter. And this xm هي بحد ذاتها the d اللي هو قايلنا إياها, so it's equal to 0.1 meter. This is how we find d. Now, part 2, motion of S2 on the inclined part OB. So هلا صار في عندي إذا بدنا نرسم الفيجر, okay, وصلت هيدي ال S2, this is O here and this is V. Okay, so this S2, okay, after the collision كان عندها the speed is equals to 5 meters per second. Okay, and then it moves along the inclined plane with the velocity v0 equal to 5i, where I is the unit vector along the x-axis parallel to OB. So this is the x-axis here, and this is v0. So سمينا إياها now. This one is v0 vector. Okay, S2 is submitted to a friction force of constant magnitude. So here we have a friction, and the part 2(1), name the external forces acting on S2 during its motion along the track. So if I want to trace it here, for example, what do we have as forces? We have the normal reaction. So we have the normal, we have the friction, we have the weight. Okay, so these are the forces. هلا إذا نحن بدنا نجي نرسمهم on the figure, this is for the part 2(2), for example. The part 2(2) show that the sum of the external forces acting on S2 during its upward motion along B is this much. So here, in order to find the sum, this means I must find summation of F external simply. So summation of F external is equal. So what we have as forces, I'll trade the forces. So now we have the weight, we have the normal, and we have the friction, which is opposite to the motion. And here I can put, so it's equals to the normal plus weight and plus friction. Now we should see, know that the motion is along the x-axis. So if I want to take only the component x-axis along the x-axis, then the summation of F external along the x-axis only, okay, it's equals to this one will هيدي الان رح تروح. الويت هي عبارة عن مين؟ It's minus mg since it's opposite sine alpha I. If I want to leave it in terms of I vector, so هيها it's opposite. This is the weight. Okay, so إذا جيت رسمت projection, it's opposite to the x-axis. And friction, it's minus Fi. And this is how I can verify that it's equal minus mg sine alpha plus F times I. هلا في ناس ممكن شو يعملوا؟ لا يعملوا projection first. So it will be minus summation لل F external equal minus mg sine alpha minus F without I vector. وبالآخر يحطوا إنه this is along x-axis, then it will be in terms of I vector. It's also true. Now the part 3, the expression of the linear momentum of S2 during its upward motion along OB is given by this one. Knowing that dp over dt is equal to the summation of F external, determine F. So the question is find the friction. We already know that here نحن كنا طلعنا summation لل F external in the previous part. It's equals to minus between bracket mg sine alpha plus f in terms of I vector. And we have that p vector is equals to minus 0.90 and plus 0.4 I vector. So the question is to find the friction. Now, according to Newton's second law, we have summation of F external, it's equals to dp over dt. Okay, let's now only substitute. So here it will be minus mg sine alpha plus f times I vector, and dp over dt, this means the derivative. So what is the derivative of this vector? The derivative of minus 0.9t, it's minus 0.9. And the derivative of 0.4 is 0. So it's minus 0.9 I. And then now I can find the friction. Since I have all the values. So نحن هون معنا ال values. We have the mass, we have the angle. So بيبقى في عنا ما نطلع ال friction. Knowing that, so here, if I want to put it in terms of إذا بدنا نشيل vector I بما إنه they are collinear, so I can put it like this: minus mg sine alpha minus f, it's equal to minus 0.9. And then now we have the mass, it's 0.08 times g, then it's 0.8. So it's 0.8 times sine 30, it's half, it's 1 over 2, minus the friction equal minus 0.9. So if you نشيل كل الماينس من equation, okay, and then the answer will become, then F will become equals to 0.5 Newton. Okay, since this is minus 0.4, نجيب لهون 0.5 Newton, then this will be the answer.